Right, so this is a very basic introduction to semantic segmentation. I should probably look at the screen. What it is, how it works, why it's useful. Right. So we'll go over the introduction of what it is, some practical examples, types of segmentation. As you mentioned, everywhere all at once is kind of the penultimate one. How we calculate accuracy, a little overview of computational requirements, can it be done in embedded, and so on. So to start, very basic explanation of what exactly segmentation is. So in this image on the left is just a normal image, and then we've segmented all the sort of components. So the windows, the railings, the roof, the front windows, they all get different colors. Colors for visualization, your actual algorithm can do anything with it, but to see that it's been segmented, we'll visualize it with different colors. This is a very contrived example, but if you can see the image, you can kind of start to see the value of segmentation. A bounding box is just a bounding box. The object could be quite small within the bounding box. When you look at the star, it's probably more non-object than actual object in that case. And there's a lot of use cases where you actually need to know the outline of the object or the actual area of the object, and you don't really get that from a bounding box alone. So types of scenarios where that's important could be autonomous vehicles, smart agriculture, drones, medical imaging. Image editing and augmentation is a pretty interesting one as well, where if you have a mask of the image, you can use it to kind of remove the object and go paste it in different places. So as a form of dataset augmentation, you could have, you got the picture of the cat and you want to see what the cat looks like in a desert or jungle environment. You can go paste it on those different environments instead of having to take more of the pictures.